How's it going, everybody? Welcome back to another .NET video. I want to talk through something that I don't think, honestly, I just don't see a lot of material on propagator blocks. So I want to talk through propagator blocks, transform blocks, action blocks, broadcast blocks, write only once blocks, write once block, and transform block. I don't know if I already said that one. I want to try to give a compelling case as to why you might want to use these in your code. It's a very functional approach to programming within the .NET within the .NET ecosystem. And basically, what this is going to allow us to do is, if I pull open my freeform application, basically what a block is if I start with the transform block, let's say here. And what I'm going to do is I'm going to take my number and I'm going to multiply it by 2. So that's my one block that contains that logic. And then I want to make another block that is going to essentially get the return. The value of this transform block is going to be passed or sent through or pushed through the pipeline to this next transform block. So these two blocks are composed together. So it's going to take the result of, x times 2, and then it's going to send to this block, and we'll just say maybe x plus 2. And then I can keep adding as many blocks as I want to. And what you'll see in my example is I use what's called a broadcast block. And what a broadcast block is it distributes the result or the return value to whatever is linked to it. So in this case, my broadcast block, I'm not going to transform anything on the x value or manipulate it, but I'm going to have 2 blocks linked to it. So I have 1 and 2. Both of those blocks are going to be, we'll have 1 transform block. I guess we'll just have 2 transform blocks for the sake of the video. So we'll have x, I don't know, plus 2 and x minus 2, something like that. Now, at the end of this block sequence, I can create what's called a write once block. And I can essentially link these transform blocks back to this write once block. Okay, and so that's going to return x. So this, if you look at this diagram here, it's very functional in the sense that it's very modular. Each of these blocks represents basically a unit of logic that we're pushing data through. So if you think in your mind in traditional like request response, or you call a service method, you're waiting, you're sending data, and you're waiting for a response back. In the TPL library, a data pipeline, you're pushing data through the pipeline. So it's a little bit different mentality in terms of how you think about how data is flowing through your system. But in essence, let me show you the code here. In essence, it's similar to calling service methods, but it's a bit different in terms of the approach. So I want to show you just some really rough code here. And I'm going to go to where I actually build the blocks here, or the links. So I just start out with, in this example in the code, I'm just starting out with a broadcast block, and then I have it linked to 2 receiving blocks. And then I have both of those linked to a consumer block. So I start with my broadcast block, send that data to both the receiver 1 and receiver 2 at the same time, and then my broadcast consumer is going to receive whichever one finishes first. So an important thing to know in this example here for this write once block is that whichever of these finishes first, that value is going to be the one that the write once block uses. And obviously it's not going to be useful in every case. I just want to show you what's possible in the TPL library. So if I have this running, and so I'm going to go ahead and pull open my console here, and I'm going to go ahead and just send 2 through that pipeline. We're going to go and execute it, and I want to go and look at the logs here. So let me pull open these logs, or the console output. So from the most recent run is this here. So those 3 console outputs, we have broadcast receiver, and we have the 2 being manipulated by all the manipulations on it. I think I multiplied it by 2 a couple times. And then this is the thread ID. So you can see that when it goes through the broadcaster, it's going to go through both of these blocks of code here. So it's taking that input of 2, multiplying it by 4, and returning the result. And the same with receiver 1. Well, this receiver 1's multiplying it by 2 instead of 4. So that's why you see 4 and 8 there. And then I have logged here the thread ID to show you that broadcast blocks basically spin up new threads for every link, which is nice because you don't have to do that explicitly. And then I have the write once block. You can see that this time it consumed 8, but if I run it a couple more times, we probably can get it to do 4. Yeah. So again, different thread IDs, but this time receiver 1 block happened to finish first, and the write once consumer consumed that. I want to do a couple of things to make this a little bit more, I think, meaningful, because there is a little bit harder use case for a write once block. What you'll see commonly, I think, or not commonly, but what you may see a write once block useful for is basically trying to use different variations of algorithms, and so whichever one finishes first, use that result. So if you ever have like competing algorithms, or you're experimenting with things, a broadcast block with a write once block is actually a pretty good way to do that, because if you have like 3 or 4 different algorithms you're testing, you can put those in a different block, and whichever one finishes first, that's the one that's going to be sent to the write once block, because it's done first. So it's going to get there the first, and then none of the other ones are going to send the value through the write once block. So very, very powerful code. And obviously, if you add an algorithm, you can just make a new block, and then you can just add a link to statement to that broadcast block, and then it automatically sends it through. And if we have a faster algorithm that we found out about, we don't have to make any new code, or we don't have to mess with any of this. We just create a new link, and if it's more efficient, if it's faster, that's the one that the write once block is going to use in that case. So very powerful code. And again, I find a lot of very compelling reasons to use the TPL library included in .NET. I don't see this come up very often to use propagator blocks, or action transform blocks. I say propagator blocks because that is what we're going to be getting to. So let me show you a couple other examples of what you can do with this style of code, because right now it's kind of just jammed in here. So we're going to make our own. This is a big topic, so it's hard to talk about this succinctly. I'm going to create a new block, and I'm going to wire it to our broadcast block. So what I'm going to do is I'm going to stop this, and I'm going to say I'm just going to call this a log block. And so we're not going to have an explicit return from this, because all we're going to do is I shouldn't call it log block. I should say just console block. We're just going to write something to the console. We can use what's called an action block. And basically, what this is you can think about it in terms of an action versus a func. A func has a return value, an action is not. So an action just is going to have an input. So you can see action t input. So what we're going to do is we're going to have it accept an int as the input, and what we are going to do is pass in our execution options. And let me go to here first and define our lambda. Oh my. Whoops, I should have did. Let me back up a little bit. All right. And let me pass in my execution options. I'm going to explain all this in a second, but let me just write this to the console. And okay, action block received. Okay, so we've just defined our unit of code here inside of a block. So I'm going to go ahead and wire this up to the broadcast block. So if we take that block and we go to the links, all we have to do to wire it up to our flow here is we can say broadcaster, which is our broadcast block, link to, and I'm going to say, what I call it, the console block, and that's it. These link options, let me explain what these are. So if I go up to here, you have a couple different options that you can manipulate the settings with. Data flow options is what's going to be used when you define these links. And this is very important because you're going to probably want to have this flag marked as true. This is very important because propagate completion basically is how you can get these pipelines running well. If a step in your block fails, let's say this transform block here failed, these blocks need to be aware that this block faulted. And so we need to specify this propagate completion to true and then pass that in. That's very important. So if you're working with these, make sure that you specify this depending on your use case. The other one is going to be our execution options. I don't need this to be max. I don't need to set this, but I just want to talk about it for the video. If you do plan on running your pipeline in with any kind of concurrency, you might need to mess with this. I would not hard code this to be like a one value. I probably would go off your processor count, and you can see that autocomplete helps me out there a little bit. Environment processor count. That's probably what I would do, just so it kind of scales with your system, depending on which machine or instance type it's running on. So that's what I probably would set it to. Some people like to do a -1 on the processor count, just to basically not scale it to every if you're on a multi-core processor. But it's up to you. It's really up to, but I would probably leave it like this personally. You have a couple other options. If you get in here, you can see you have bounded capacity, which bounded capacity, if we hover over what bounded capacity is, you can see that it gets or sets a maximum number of messages that may be buffered by the block. So basically, another concept or another block you can use is a buffer block. And if you ever work with like RabbitMQ or something that deals with a buffer, RabbitMQ is this concept of a prefetch count that basically utilizes an internal buffer to house the messages prior to actual consumption by way of the consumer. So your bounded capacity is basically going to be, if you don't want things to be processed multiples at a time, you would set this to 1. If you want to, let's say, kick this up to, if you're working with, again, RabbitMQ, because that's what I know pretty well. If you're using RabbitMQ, if you're using any kind of batch consumer on RabbitMQ, like that video I made very recently, that has a max value of 10, meaning you can prefetch, or not prefetch, you can receive 10 messages off the queue in a batch up to 10. So if you're working in that environment and your pipeline is set up to run concurrently, you may want to bump this up to what your expected batch count would be. So again, that takes a bit of experimentation to check what you want for bounded capacity. In my specific case for the video, I don't need to set this because we're not doing anything. We're not running our pipeline in parallel. And I'll explain that again coming up. But we have a couple other options. Let me get back to some other options here. We have ensured order. So if you need things to be processed in the order that they were pushed through the pipeline, you can set that. Max messages per task, name format, single producer constraint, which single producer constraint is a really, really fascinating one, because the fact that is even a flag on these options shows you, I think, the power of creating a pipeline. Because, again, you can have multiple messages or multiple producers. Let's say if you're using a buffer block, you could have multiple producers to that buffer block and then link it. You can just make these really, really powerful. These are super powerful things to do. One thing you're probably going to want to definitely set is a cancellation token. I probably should have went over the other options on the data flow link, but we won't get into that right now. Let me actually create a cancellation token and then pass that in. CTS.token. So the nice thing about the pipeline is that it handles or has support for cancellation tokens. So let's say that you define let's say you define, like, whoa. Hold on. Cancel after. We want a timeout of 30 seconds. If you have that specified in your cancellation token, your pipeline will bail out or short or stop after 30 seconds at whatever block it was on. So again, we can set that. I don't want that to take effect, but I'm just going to bump it up to 90 and leave it in there to show you how. And again, so we have all our settings set. If I can illustrate one definitely to make sure that you have, is this propagate completion set to true. That one, again, I just want to highlight that one as being very important. So those are the two main options. The execution options are passed on the individual block, and the link options are passed on the specific links. So again, I made a action block at the top here. I'm just writing out to the console, and I have it linked to my broadcast block. So I'm going to go ahead and run this, and I'm going to show you the output of that. Again, these things are, this is such a large topic, so it's hard to talk about this in one go, but hopefully this is making a compelling reason as to why these are really powerful. All right, so I'm going to send 2 again, just because, and I'm going to go into my app, and you can see that the action block wrote to the console. So not a lot of code to add it inside of our link or our pipeline. So if you want to think about this in a more practical sense, like if you have a pipeline that's doing some serious work, and let's say that you needed to add some kind of additional piece of logic, you need to send it to, write data to an S3 bucket in AWS, you could theoretically introduce a broadcast block into the sequence of your pipeline, and then create an action block to wire it up to to AWS and post that data to S3. And you wouldn't interrupt any of the flow, because your data is essentially it's broadcasted. It's I don't want to say copied, but it's cloned to that block uh, to be acted on. And it's very, very powerful. But I'm going to show you how to make it even a little bit more powerful, because right now everything is obviously just crammed in this huge method of broadcast data. And I want to get into the concept of what a propagator block is, because in my opinion, propagator blocks are a way to uh, not only kind of contain all this code in like a better unit, if you want to think about it in like in F sharp terms, but a unit, we want to just encapsulate all the logic a little bit better. So let's go ahead and write a method. So we're going to go ahead and go public async. I guess it could be a task. Or no, sorry, not task. What am I doing? We are making a propagator block. Let me highlight over the signature there. So propagator block, if it'll highlight over there, it says it represents a data flow block that is both a target for data and a source of data. And I'm going to keep in the same vein as of what I was just doing. I'm going to give it an input of int and a return of int. And I am going to build what do we want to call this? Build car block, because this is our car data API. All right. So what I have here, it's giving me squiggles because I haven't returned anything. What we need to do is basically move this chain here into our I'm going to copy this stuff. It's going to be a little messy at first, but I'm just going to hopefully do it in a way that makes sense. So let me copy that, delete it, and I'm going to paste it in here. So I've moved the logic inside of this message or method, but I still need to return, that actual propagator block. So if I come down here, what I can do is basically encapsulate everything inside of a propagator block. And how that works is, let me pull up one thing. I always get confused on the syntax, but I wrote up an article on Medium a couple years ago, I think, that I always reference. It's helpful. The more I do software engineering, the more I realize how important it is to save your own code. Like, what I mean by that is like save like your personal project code and just like create snippets that you can reference back to, because it honestly becomes like your notes for later, because it's impossible to remember all the nuanced syntax and everything. But if you write up some notes for yourself, it'll be super helpful to reference. So what I'm referencing now is this bit of syntax. I forgot that it's called data flow block. And what data flow block is the implementation of propagator block. And what we can do is, if we hover over that data flow block, you can see that it provides a set of static methods for working with data flow blocks, and that's exactly what we're doing. So it's a static class. And the thing that we are going to be doing is this one right here, is this encapsulate. So it's encapsulate a target and a source into a single propagator. And you can see that it implements propagator block. And what we need to do is define the start of our pipeline. So what is the first block in our sequence? So you can see, if we reference here, if we look at the diagram of what we have, you basically have to define, okay, what's the beginning of our pipeline. So you have to figure out what that block is for you. So for us, it's going to be, I believe, this broadcast block. That's going to be our first one. So the broadcast block, then we have to define, okay, where does this end? In our case, it's going to be this write once block. So we have to just look at your diagram and say, okay, what's the last link in the sequence? So for us, it's the broadcast consumer. And then you can see that we can call it a day there. I forget if there's, can you pass settings into that? I don't think you can. I might be wrong though. Target source, does it give us another parameter for any kind of settings? I don't think you can pass. No, okay. So now we've satisfied what we need for this method here. Whoops, what did I miss? Oh, am I not? Hold on. Int. There we go. Can't make it async. All right. So now I've returned that. So let me scroll up here, and again, this is the same code, but now I can call this inside of here. And so I'm just going to say car data block is equal to build car block. And so now what this gives us is a way to send data through our pipeline. And that's how we can change that. So obviously you're not going to want to keep this in the same file. You're going to want to break out, all these different blocks into probably their own, at minimum their own classes or a file, however you want to structure this. But you really, I think, should push to get to this, right? And this is not done fully, but again, we're working through the code. There's a lot to do here, but this is just getting us there. So what we're working towards is building the pipeline, being able to push data through asynchronously, and receive that data back through. And what's important is well, actually, I tell you what, let's run this to make sure it's still working. You never know with these things. You always want to make sure they're still working. All right, let's go ahead and execute that. And let's look back at our console. And okay, we are good to go. So why I think that this is a good approach to use propagator blocks is because you can build towards this. And that way you get a complete object that you can push data through, mark as complete, and receive all on that propagator block. And so you can encapsulate things like this. And I'm a really big fan of this encapsulate method because I think it makes sense conceptually in terms of like what these things are, right? Because it's a pipeline. If you ever read about data pipelines or even data meshes, it's a good way to think about this thing. It exists in its own encapsulation, and so encapsulate is a really good word for that. And again, just experiment with this on your own, but you can make some really, really powerful stuff with this. And let me show you why I like these so much. I am actually going to change this because I don't want to. I'm gonna actually simplify our flow a little bit because I don't want to have that. Well, no, let me keep this. I was gonna say like I was gonna make it a little bit more, not have my write once consumer. Do I have it? So I have a transform block. I have an action block. We have a broadcast block. I'm just trying to think of more. I think we'll keep this covers a bit. We'll keep that. Okay, so let's go down to our code here. So we've built our propagator block, we've encapsulated it, and we can now push data through a pipeline. So let me break off a bit from my parameter because what I want to do is send like a lot of data through this. And so I'm just gonna create, again, just keep it simple. I'm just gonna create a list of ints. Var ints is equal to actually that'll that works pretty well. We're gonna define the top range for that list of ints. And what I want to do is I'm just going to do a simple for each, and I'm going to push data through my pipeline. Complete. And okay, so I'm now essentially specifying the top end of my range, but now I'm just creating a list of ints for myself. I'm going to send all those through my pipeline. Again, you don't have to do this sequentially like in a for each. You can do it in a parallel for each if you have your pipeline set up correctly. Obviously, you're going to want to make sure that you're using thread safe collections if you need to be, if you're passing references to collections or anything like that. So again, depends on how you have it set up, but I'm just going to leave it like this for this video. But the next thing that is very important, so whenever you I should say that also there are a couple different methods available to you to send. You can do the you can do a post, which is not asynchronous. But if you don't want to do, if you're not want to use asynchronous code, you can do that. I'm choosing to use the send async, so you're just going to want to await that. So again, depends on how you want to do it, but this is how I'm doing it. The next one that you're going to want to make sure, this is as important as the propagate completion flag. You're going to want to make sure that you flag your propagator block as complete. And this is another reason I like using propagator blocks, is because it makes flagging completions a little bit more easy because you have everything encapsulated in a single unit. So you can just call complete on the your objects, your propagator block objects. So complete is necessary because it signals to the pipeline that we're done sending data to it. And if you hover over complete, it says, it signals to the iDataFlow block that it should not accept nor produce any more messages, nor consume any more postponed messages. So if we actually, let me, that description can be a little bit misleading, because if you drill into that object, you'll see a couple things that we have available to us. We have complete, but then we have at the bottom completion. And if you hover over that, it says it represents the asynchronous operation and completion of the data flow block. On the surface, at least in my opinion, when I read this, it would, to me, it seems like you have to call completion before complete, because complete to me signals that everything's done. But that's not the way it is. Completion depends on the complete flag being called, which is very it feels like it's backwards to me, but that is how it's done. There's some other things too. A lot of this, to be honest, I haven't used like I haven't used release reservation or reserve message. I haven't used offer message either. So there's so much built into these pipelines that you can take advantage of. What I'm showing you is basically just like basic implementation. You can get crazy advanced stuff in here. All right, so what I want to call out though is you can see that completion is a task. So you can call await completion like that. Whoops. But I want to show you something, because this is one of the main gotchas of these things. So we're going to do this, and we're going to say, okay, we don't really want to get any output, from these things. We might want to receive. I want to run this, and I want to show you what happens. So we're gonna debug that. We have it marked as complete. We're gonna await completion, and we should be fine, right? It should all be working. But I want to show you what happens because there's always a gotcha. So I'm gonna go ahead and go to our code again, and I'm gonna set the upper bound to 10 just to send data through the pipeline. I'm gonna execute this, and okay, we got that. It's sent all through the pipeline, 10 ints, and I'm gonna continue. And what we got was an internal server error, and it says a task was canceled. And you may be thinking, okay, well, why was it canceled? It's kind of weird, right? So let me go back to the code here. What we need to do is when you await completion, right? We push data through the pipeline, and this is where you have to think about it basically in the reverse of how you typically think about interacting with just standard like MVC style .NET code. When you send data through the pipeline, you're not getting the result back, meaning that you have basically set up work to be done. You have to receive it back through the pipeline essentially. So we're pushing it. We have to receive it. So receiving it is basically what's going to complete that task in a sense, is how you can think about it. So you may be thinking to yourself, okay, well, we've pushed 10 ints through our pipeline, and we need to await the completion of all those ints. How do we get the result back? And it would be tempting to say like var result is equal to car data block. We have some things. Okay, we have a receive async. We can await that. Receive async. But if we hover over to receive async, it says asynchronously receives a value from a specified source. But the problem is it's only one value, and you still don't know if you have more values. And so what the propagator blocks give us actually to handle this issue is this property right here. So if we do car data block, we have if we scroll down to the bottom, we have this output available async that's going to be very important for us. So if we hover over that, it says that this is let me await that. You can say that this is provides a task that asynchronously monitors the source for available output. So it returns a task result that informs of whether and when more output is available. If when the task completes, its result is true, more output is available in the source, though another consumer of the data may retrieve the data. If it returns false, more output is not and will never be available due to the source completing prior to output being available. So there's a lot of words, and it's very confusing. But what you can do basically is structure this in a while loop like that, and autocomplete's going to tell me to send. We don't want to send. We do not want to send. We want to get the result. All right. And I need to move that. I don't want that up there. All right. Okay. All right. So let me walk through this. So we've built our pipeline. We've sent data through the pipeline. We've marked the pipeline as complete, meaning we're not sending any more data through the pipeline. We process what data is in the pipeline. We receive it. We use this monitor task to tell us if there is more data available to us. When that returns false, we exit out of the while loop. We mark the pipeline as completion. And let's go ahead and debug this. And let's go back to our pipeline, and assuming we set up everything correctly, because it really, these pipelines, the syntax is a little odd, but once you get it set up, you're golden. So let me All right, I do have, oh, I tell you what, I do have to set up something else. Hold on a second. You can see that my code is hanging. And so let's actually look at this because this is an interesting issue. Because on the surface, I thought that we got everything set up correctly in our block. But let me take a look at this. Let me pause out of that because we got caught in an infinite loop. Let me take a look at what's going on here. All right, so we're back after I spent about 15 minutes just on my own, just trying to figure out why it was hanging, and I found out why. And I'm very glad that I'm making this video because I didn't know this, and now I know. Evidently, one of the gotchas with data flow block or iPropagator block is that you can't end an iPropagator block with a write once block because the task will never be, it'll leave a hanging task. That's fascinating. And I don't know where you would know this. If somebody knows the specifics of why not, I would love to know because it seems like it has a return value. So what I had to fix for me, what I had to do was I had to create another transform block to just be the ending block that literally just returns the value that I'm receiving into it. So I just added that to the end of my chain, and I ended my encapsulation with that ending transform block. So that now changes our diagram to now end in a transform block. I would love to know why. That's a huge gotcha, in my opinion, because how would you know that? So let me go through the code. So that's my amended graph. So let me go back to the code. So the fix for me was to add an ending link to a transform block and just make that my end of my encapsulation. So let me go to where I'm building this again because that is so fascinating. I'm gonna be thinking about that for a while now. Because this stuff didn't change, right? You have to build the pipeline. You have to push data through your pipeline. You have to mark the pipeline as complete. You have to await, available output, so monitor it using the provided method. You have to receive all your, values through there, and you have to await the completion. And so when I attempted to end on the write once, it was being stuck perpetually inside of this while loop because it was always registering as there was still more available output because it was never those tasks were never being awaited. If I had to guess, no, see, that wouldn't make sense. I was gonna say my guess was gonna be that if you attempt to end on a write once block, maybe it doesn't ever fully complete the tasks of the blocks that don't send the data to the write once block. Maybe? I don't know. That's fascinating. But it's still, yeah, I'm not sure. If somebody knows, let me know because I have not seen that show up in when I've read about this. Very fascinating. I'm glad I found that because that was gonna, yeah, that's weird. I guess let me step through this and show you what's happening. So I built the block, step through it. We have a range of error numbers. We're now going to push data through the pipeline. Let me go to my next breakpoint. We marked the pipeline as complete. And now if we come in here, you can see that it skips down to, let me, I should have set my breakpoint on the receive. Let me do it again. All right, let me get into that while. Let me step over that, and let's look at one of the results. So you can see we have a 4 for that one. Let me, okay. All right, and let me go to my console. Oh, did I? Wait, let me, oh, am I still getting an error? Oh, wait a second now. We might have found another gotcha with those right once. I feel like this is so fascinating. You can see how we encountered an error with that right. I think that right once block is really just messing things up. Because if we were to change, let me do a couple things here. That is so fascinating. Maybe right once blocks don't work that well inside of a propagator block. That could be what's going on. Maybe right once blocks never handle completion of the tasks broadcasted to them. Maybe is that our problem? Maybe it doesn't work inside of an environment in a propagator block. Because if I bet you if I change, I'm going to change my setup here. I'm going to keep the broadcast block, but I'm going to make these action blocks. And then not return a result. And I'm just going to log what I did to the result. So let me change these to action blocks. Actually, I'm going to keep one as a transform block because I still need to link. And I'm going to get rid of the, okay, we can't have a link on a, okay, perfect. Now where I want to link it is to my ending block instead of my consumer. Let me make sure. So I'm going to get rid of my right once block, and I'm going to instead link it to my ending block. So now the new flow is, instead of me using a right once block, I'm going to now, perfect. Okay, send it back. That is so fascinating. So now I changed my flow a little bit. I'm not using a right once block, and because you can see that I canceled a task prematurely. So let me start this again, and let's send data through. This is so fascinating. All right, it's because I was like, wait, it didn't get the result of all of them. All right, let me. Oh, very interesting. Where am I getting the? Oh, wait. No, I'm still getting the error. Huh. Was that where did that log come from? Action block received. Yeah, it's all we're sending it through just fine. Huh. Action block received 2. Yeah, it's working perfect. Action block received 2. Very interesting. Let me undo that and let me go back to what I had. Maybe it was just because we were finding a lot of interesting things out about these propagator blocks, I can tell you that. No. I'm going to restart that. So I reverted to where I was at before. Oh, look at that. Look at that. We created a loop. Yes. Okay. That's actually... that. Do you see that? What? Look at that thing. That's amazing. Because we're stuck in the while loop again. We are stuck right here just receiving to no end the same values when I use the right ones. That is fascinating. All right, so if I go back to what I just set up, get rid of the right ones. This is pretty much as close to realistic of like what programming looks like on a day-to-day. Let me pull up my... All right, so I'm going to execute this, and I just want to look at my logs. Yeah. I want to send one number through. Yeah. Let me clear that. Yeah. Our pipeline is good. We're spamming it with data. I'm going to send a lot of data. I'm going to send 1,000. Woo! I think we broke it. Yeah, we sent too much data at it. Because we did a I think we definitely created too many tasks or too many threads. I think, did we? We probably spun up too many threads. Because yeah, definitely. Because we're making a new thread. I thought we limited. Didn't we limit the pair? Or, that's pretty neat though. How many numbers was I sending? I put 1,000 in there. A numeral range. I sent 1,000 at it. It's about 1,000 threads then. So yeah, that we sent a lot of data. Yeah, you can mess with these things. Man, I'm going to be thinking about... I'm glad I got this on video because this is good notes for myself about write once blocks. So let's go back to the diagram. So let me amend my previous statement about using write once blocks inside of a propagator block. Apparently, you can't do that in a way that allows for completion of tasks. That's so... I mean, did I set it up incorrectly? I don't think so, because I have all the flags set, unless I'm just missing some property or something. But that is fascinating. Let me go into another thing that you can set up, because it's so... Let me move past the write once blocks now. I'm going to stick with this being our setup here. So we have a transform block going to a broadcast block, and then ultimately ending on a transform block coming from, these are action blocks now. So action block, transform block. Okay, so let me show you one thing in here, and this video is already over an hour, but it's more or less just notes for myself. But let me go up to these links again. All right, let's go to these links. Where are they at? Okay, so You see here, I have encapsulation, I have link to, and I have the propagate completion. The thing that you also have to think about is when something happens, when an error is thrown. How does a later block know that a previous block faulted? And so it works on tasks. And what we can do, basically how we can write this pipeline in a way where we can notify, hey, a block faulted, is we have to write that manually. But once you get that in place, you don't really have to touch it again. So I'm just going to write it above here. So if you think about what blocks are, you have a source. I'm just going to write some pseudocode for us first, but we have a source and we have a target. That's basically what we're dealing with. So when the source faults, we need to notify that the target, of the fault. So what we can do is we can, with .NET, you have task, everything works with, it works with task. You can do task dot continue with, and continue with, let me actually write code here. I do have to put it, let me go inside of a method real fast. Task dot continue, I need to get something with a task. Let me go to it. I need something that's async. Ending block. Okay. What is ending block? Give me something that's continue with. Man, all right, I gotta find something. Jeez. Give me a second here. All right. I'm gonna make a new method so I can set up this logic here. What is that property called? Propagate completion? All right, well, I'm going to say, we're just going to call this error just for the fun of it. Public void error. And what we need to do is we have to pass in data flow block. Yes. So again, we have a target and we have a source, I believe. Oh, hold on, let me flip those. Source and target. All right. This is going to be our method here. What? I think it's I. Yeah, we had to use the interface. Okay, so we have now. There it is. It's on the completion of the task. I always forget that. All right. So, okay, we got here. So, what we have to wire up. This is such a long video, but what we have to wire up is basically if block A, this block here, transform block, if that completes, and if it errors or if it faults, we got to say, hey, the next block, we got to tell them that it faulted. And let's look at how to do that. So let me go here. So continue with, if we hover over this, so completion of a task, you have this handy method in .NET called continue with. And if it gives me the IntelliSense here. Oh, Oh, tell me about it. I had it in a second. Nope. I just want to give me the pop-up window. It's not gonna give it to me. It accepts an action. So I need to define. Oh, here it is. All right. Oh, that is faulted. All right. So this continue with, we can leave it like this, but this continue with, okay, there it is. It creates a continuation that executes asynchronously when the target task completes. That's very handy for us because we have already specified to propagate the completion. The completion of the task is going to be available to us in here, but we just have to wire it up manually in order to take advantage of the fault propagation. So what we can do is we can now get access to that is faulted, which is perfect because we can set up logic to say, hey, if that block faulted, otherwise do this. So say if we get access to all these things here. So what we can do is, I should probably call this the source just to make it clear what this is. Well, it's on the source. I'm just going to leave it as O. So what we have here is the fault from the source. We got to send it up to the target. Very important. So if we click, type on the target, you can see that autocomplete basically tells us what to do. And that's what we have to do. And so this little bit of extra wiring that is necessary will allow us to properly throw exceptions or handle exceptions in the pipeline and have them propagate up. And so by this way, we're handling the completion of the task appropriately, checking if it faults, and if it faults, sending that up to the later part of the pipeline. So, and again, you can add in whatever kind of code you want, but this is that manual kind of intervention step we have to do. So we're not done yet. We have to wire it up the same way that we basically wired up the links. So wherever you wired up your links, if you basically go to, we could say like, okay, on my broadcaster block, we can now call, or what am I doing? We can call that error method, and we can give it the target and the source. So basically, you can just kind of group these, and so that would actually, just copy and paste basically the, these, for the source, right? Source, destination. And just kind of do it that way to build your links. So in this case, I want to make that 2. Then we go to the next one, and this one is going to be from the broadcaster to the console block, and the last one will be from the broadcast receiver 2, which is our transform block, all the way down to our ending block. And so now we have a complete linkage of not only success propagation, but also the faults on the task. So we've built a link, but we've also built our necessary error or fault linkage as well. That's not super explicitly called out as something to do whenever you're working with these pipelines, but it's something that you probably should set up, and I'll show you why. Because if we go to, I'm going to go to my transform block, and instead of returning, I'm actually going to throw an exception, and I'm going to call my exception broke. So now instead of returning, essentially completing the pipeline, I'm going to throw an exception. So I'm going to go ahead and start this, and I'm going to pull open my console, and let's go back to my pipeline. I'm just going to send one through, and you can see that we get an error. So you can see that this is hard to see in this console. Task was canceled. Oh, wait a second. Where is broke? Broadcast receiver 2. Okay. That is, in fact, my exception. I would like it to be a little bit more clean, but if I take out that throw, and go back to my pipeline, and I send that through, we don't see that same error. So obviously you can clean up a little bit. You probably don't want to just throw an exception. It's more for like catching if something happened and notifying the next one. But it's not really about like building the error handling. It's giving you a little bit tighter control over what actually happens when a block in your pipeline faults. Because obviously we left this blank, but you probably would want to do something if it didn't fault, meaning like you can log or you can do something. But this gives you pretty tight control over what happens. And I want to show you one last thing now that we've kind of built our little pipeline here. I'm going to go up to where I'm actually sending data through the pipeline. Where is that? Okay. Instead of a for each, I'm going to do a parallel for each. Parallel for each. Alrighty. Wait that. And I believe it has to just be async there. Okay. Oh. Probably don't want to do using async. Let's see what that does for us now. Obviously, that's a naive way of doing parallelism, but we'll just see if it... I'm just going to bump this up to 10, and let's post some stuff through our... All right, we got some good data here. Pretty fast, too. Let's make that 100, see what happens. See if we break it. Yeah, we broke it. We spin up too many tasks. All right. Or we spin up too many threads. So you do have to be mindful. You don't want to spin up 100. You don't want to spin up 100 threads. Obviously, if you're on one machine, 10 is just fine, but not 100. All right, that's cool. And what's neat about this is that in order to make this parallel the pipeline, we didn't have to do any we didn't have to do a ton of additional code in order to, push data through a pipeline in parallel. Obviously, you have to do a lot of more, you still have to process the data, you have to receive it. So it's something to think about as well. But it just kind of works. And obviously, like, this is an hour and a half video. This is a very nuanced bit of .NET. It's very opinionated code in the sense that there's some things that you have to just get right. And looking at this, there's some things here that are probably still up for debate in terms of my implementation of this. And some of it probably revolves around the use of these options. You want to make sure that your option's correct. But I'm just going to remove that. This part here is really where you need to dial in your settings. And you can see that we ran into a problem with the write once block. I didn't know that it was limited in terms of its use in iPropagator blocks. But again, this is where you just have to figure this stuff out. Like you just have to experiment with it. The only way you're going to figure it out is by experimenting with it. So, and again, there's still room for improvement, and I'm sure I did something wrong in this code, but I just want to get across what's possible in .NET with the with tasks, with this style of programming. But this stuff here, to me, is still confusing because complete and completion, it's a different way of thinking about it, and it's a different way of thinking about pushing data through your code, and it's a different way of thinking about it and receiving that data through the pipeline back to you. So it kind of hurts my brain to think about it that long, but it's late and I gotta finish this video. So let me know what y'all think about propagator blocks and blocks in general in .NET. I think there's a real compelling use case for them. Let me know what y'all think though. Thanks so much for watching. I'll see you in the next one.